And yeah, so we are currently in the Isar Valley, and most of our events we organize here. So yeah, but before I start the event, I would like to know you guys better. So we can just play a little questions game. You can just raise your hand if you have an answer to the question. So how many of you are students? Oh, so that's basically the, okay, this is like the most part, right? That's cool. And how many of you heard about the Google Developer student clubs? That's also a lot of people. That's really cool, actually. I'm glad about that. And how many of you guys participated at a event from us? Okay, that's also quite a lot of people. So I'm really actually glad to see these numbers because I didn't expect that. But yeah, let's me then introduce myself. I am Maria. I'm a part of the core team member, and we, the core team, are responsible for organizing all the GDSC events. I joined the core team in October 2021, and we have some other members right here. For example, both of them here. Do you want to introduce yourselves or?
Yeah, hi, I'm Philip. I joined the GDSC shortly, like a month ago, and enjoying it.
Yeah, and I'm Leanda. I'm joined GDSC last September and also the lead for this and like for last and this semester. Yeah, really glad to have you all here.
Yep, we are really cool to see you here. But before we again start the actual event, I want to quickly introduce you to what Google Developer Student Clubs are, especially to those who haven't heard about them yet. So this is a definition I found on the official website of Google. Google Developer Student Clubs, or GDSC for short, are community groups for college and university students interested in Google Developer technologies. But of course, we are not only limited to Google Developer technologies. You can also learn a lot about other technologies at our club and participate not only at technical events, but also at soft skill events and community events and I don't know, networking events. We have a lot of different stuff here. For example, these are some photos of some of the last events we had. On the left side, you can see a workshop. I think this was a Google Cloud workshop. And on the right side, you can see a networking event that we organized in collaboration with Manage and More. And we have a lot of more events. So just to take a sneak peek to motivate you to join future events. For example, we had a lot of technical events like security, Google Cloud, quantum AI, web development, and stuff like that. We also had competitions like Capture the Flag competition or Google Solution Challenge Hackathon. And we also had a lot of non-technical events such as CV coaching and interview tips and how to get into a Google internship and stuff like that. So if you're interested, you can join us. And these are the main 3 points why you should actually join us. The first point is learn. Like I mentioned it already, you can learn a lot of different skills, not only technical, but also non-technical ones. You can connect, so that means that you can meet people at our events, make friends, and also connect with experts and speakers as well. And the third point is grow. So you can grow, again, your skills, like I already mentioned that, and you can also advance your career, your, again, skills and network. Maybe a short story from myself. I never knew how to program before I started my bachelor's in computer science. And I almost stopped studying because it was so hard for me. But then I joined GDSC and started participating at the events, got a lot of different skills. I participated at the solution challenge, was able to win 2 times. And thanks to DSC, I also got a Google internship. So you guys should actually consider joining our events, and the same will happen for you. Yeah, so now I just hand on over the microphone to Dr. Han Xiao, and we can start the actual event. So please applause.
All right. So should I?
You can use the microphone.
Okay. All right. So everybody hear me? Also online? Okay, cool. What is the applause sounds? Oh, cool. All right. So very honored to be here to talk about the study flow and neural search, generative art, all these kind of things. And so this session is planned to be like a 2-part. And in the first part, I will talk about some, engineering stuff, background, theoretical background about generative art, about neural search, all this kind of buzzword. I hope to explain this very clearly to you, right? And then the second part will be the fun part, right? So everybody can create their generative art using our GPU, right? So what I'm talking about today? So to give you an idea, right? So just to give you an idea, this is going to be what you can do, after the second part of this session, right? After this workshop, right? So you can input a text, a sentence, right? Like ocean beach, front view in Van Gogh style, right? And then it will generate some art, right? Kind of pictures for you, right? So everybody can do this after this talk. Right? And there is another, another case, a Statue of Liberty wearing a VR headset. So it doesn't necessarily to be realistic, as you can see. Right? So unleash your creativity, right? And try to do something funny and crazy, right? So there is also a very romantic one, the painting of a couple kissing in nebula, right? Very nice. So these are the real artwork that generate by DALL-E flow. Basically, the main character that we are going to talk about today, right? And as I said, so two parts. First part is boring tech talk, but it helps you to understand what is behind DALL-E flow, right? What is neural search? What is the deep learning, and how this affect all this human creativity? How can they if you are artist, you're probably very depressed because the robot is not taking your job away. And in the second part, we will basically be the evil guy. Right? We will try using DALL-E flow to generate some artwork. And I also bring two teaching assistants, DALL-E and Aladdin's. They're also from Jina AI. But we didn't realize there's not so many. There are so many people here, so they are right now working on upscaling our server, in real time. So in the first 45 minutes. So hopefully, we can. Right now we have 8 GPUs for you to use, but I guess we did some stress tests, benchmark, all these kind of things. I think the queuing time is 8 minutes. So that means for each request, you will wait for 8 minutes to finish the everything. And I think it's not very. I'm not very satisfied of that. So I bring these two guys to upscale the things. Right. And then in the second part, the most interesting is that we will have a small contest, right? So it's not like you generate some random artwork that nobody cares. We do care, right? So we will have a voting system. And everybody can vote on the favorite artwork. Right? So we will select the 10 most liked artwork, and then we will give you a swag, right? So it's a very nice swag, and is in the bags, right? And then we also go a little bit of philosophy, right? So, I mean, we can talk about, we also have like a 2 best rapper, at the end, best rapper award. The first is about summarizing the whole talk, right? So one philosophy question I want to ask you is, after all this talk, after all the hands-on session, tell me what is the limitation of the generative art, today, right? And then the second philosophical question is generative art means an end to amateur artists, right? I always say that it's like there are different tiers of artists, right? The top tier artists present their work in Paris in the museum, right? The second tier artists present their work on Berlin Wall, right? On Berlin Mauer, right? And the third tier artists present their work as an NFT on the blockchain. Okay, so a little bit about our company. I will just not do the bragging because we are already famous enough. I mean, we are a pretty young company, founded in 2020 in February. Right now we have 15 members in total. We are based in Berlin. Berlin is our headquarters, but we also have offices in US, in China, and we have people from other cities in Europe. In India, so it's a very international company, and we are one of the fastest growing AI startup in the world. So we raised $38 million in just 2 years, right? And we are, ranked at AI 100 by CB Insights in 2021 and this year, right? And also Forbes AI 30 in 2020, right? So very, very, very ambitious company, and what we are doing here is neural search. All right, so I will explain this neural search later, but if you go to GitHub, if you search this term, I believe the first result return from Google is Jina, right? So we basically create a lot of open source projects that cover all the landscapes, the full stack, the end-to-end solution of neural search, right? So I will explain all this components later, right? So all of the things that you see on the screen, they are open source projects. So you can find it on GitHub. So some of them are very popular, like a Jina, we have like a 14,000 stars. Clip as service, we have like more than 10,000 stars on GitHub. So as I said, today's content, the first boring part, the tech part, is divided into like 4 sections, right? So first we talk about neural search. I mean, I don't know what is your background in machine learning, so you probably learn, oh, when we first learn machine learning, there is a classifier. You know, when I learned machine learning back in 2009, right? The first thing I learned is not deep neural networks, but naive Bayes, but linear regression, right? All these kind of things, and support vector machines. Who knows support vector machines? Oh, cool. It is still like still a thing, right? Okay. And so basically all these things is kind of like, we call it discriminative models, right? And on the contrary, there is another family of machine learning. It's called generative machine learning, right? The most simplest generative machine learning is basically Markov chain, right? Where you build a Markov chain, you keep sampling the next state, right? It's kind of generative. And so the neural search part is basically focused more on the discriminative part, and the DALL-E and diffusion, all this generative art is of course focused more on the generative part. So let's first talk about neural search. Okay, so here's an interview question, right? So let's say if you interview for Google, and then you want to go to Google machine learning groups, and then the question is, okay, so I have a database, right, with 60,000 images, right, fashion articles, right? And I took a picture. I used my cell phone to take a picture, and I want you to build a system that can find visually similar pictures from these 60,000 images, right? How would you do that, right? So it looks very like a very old, shops look. This kind of like an image search, semantic search, cliche. But if you really want to program it, right, it is not that simple, right? It is like you have to use probably some deep learning stuff, and then you have to serve via REST API, all these kind of things. Right? It's not that simple. Right? By the way, do you know what is this data set is called? Yes. Do you know who created it? Yes. Very nice. You are hired, right? And okay, so the next question is a little bit, more challenging, right? So we talk about static images, right? So static images seems very simple. In fact, for the fashion image data set, it is so simple that you don't even have to use deep learning, right? You can just use SVD, right? Singular value decomposition, to get some, eigenvalues, and use this eigenvalues as a feature, right? In fact, only 3 eigenvalues is enough to represent the whole thing, because the data set is so simple, right? And it's black-white, right? So let's look at another images, another use cases. So this is a real use cases from one of our clients. So they are a game engine company. It's like they build their own Unity, right? So I don't know how many of you are build computer games, but a lot of games are built on top of Unity, right? So they're building their own game engine on top of Unity, and they have an asset store, right? So in this asset store, you have a lot of 3D mesh data, right? And now I ask you the same question, right? I say that, okay, so I have a 3D mesh. So I have a dinosaur. I drag this dinosaur into the scene, into the game scene, right? I want to right click on the dinosaur, and I want to find similar dinosaurs or similar monsters that somehow fit into the scene. How can I do that? So now it becomes a little bit tricky, right? Anyone has an idea? Like how can we do that? Yeah.
Like you can just special graph condition, and these coefficients to find closed graphs.
Yeah. So that's kind of one way, right? So when I first have this problem, when our client, first approaches me. By the way, do we have any other ideas? How can we do this? Yeah, please. Yes, but how to embed the mesh into vector? Very nice. You are also hired. Okay, so when I first have this problem, right? I come up with some heuristic because I personally don't like very fancy machine learning solution. I try to build things from simplest as possible, right? I try to take some screenshot, right? I try to take some screenshot. It's like a cube. You have 6 faces of the cube, and then I try to take a screenshot 6 times from different angles. And then I try to convert the mesh search back into the static image search, right? But of course, the result is pretty bad, right? And later we found out, okay, so there is a kind of like 3D convolution neural network, and there is a point net, which can very nicely solve this problem. But as I said, the problem is about first, how do you represent this real world object into some vector representation? And then secondly, how do you search nearest neighbors on these vector representations? So here's another like very old cliche, right? Chatbot, right? Chatbot. But in this case, it's a question answer chatbot. It's not like an open, you can flirt the chatbot. It's not like that, right? So it's a closed domain question answer, right? How many of you knows Fast API? Okay. How many of you go to their documentation website and notice that there is a chatbot on the corner, right? In the right corner. And this is powered by Jina, right? And probably you'll say, oh, that sucks, right? So that chatbot is really like a low quality, right? Okay, so anyway, but it's basically like open domain question answer. It's one of the classic problem in neural search, right? So question answering itself is not something new, right? So if I ask you to build a question answering chatbot, there are many ways, right? You can ask me, okay, so what kind of data do we have? Do we have a kind of like a CSV, right? A table data where the first column is all the questions and then second column is all the answers? Do we have this kind of data? If your boss says that, yes, we do have this kind of data, then you don't even to use like a BERT or this kind of model, right? You just do question to question, semantic matching, and then use hash map to directly map the question to the answers. But in this case, it's different, right? On Fast API, is this technical documentation. You can ask a lot of things about this technical documentation, right? So there is no written solution, written answer in this technical documentation. So you have to figure it out, right? And this procedure is also kind of neural search. Right? So let's summarize all the neural search that I listed so far, right? Okay, so it's not very easy to read. So I will just basically this, you can group into so we talk about image to image search, we talk about video to video, audio to audio search. So all this kind of multimodality search belongs to, they belong to neural search, right? And there are also some very interesting cases. You want your input is an image, and then you want to search for text, or your input is audio clip, you want to search for images. So those are cross-modality search, right? Of course, it's not easy to use classic machine learning to enable that. So that's why we need deep learning. And this is basically neural search. Right? So if I use one sentence to summarize neural search, it's basically use deep learning to solve information retrieval problem, on the multimedia data. Right? So that's neural search. Okay, so is neural search solved? Like if it is solved, then why do we start a company and doing that? Actually, there are a couple of problems, like fundamental problems in neural search. Right? The first thing is, how do you represent the real world object into a vector representation, right? How do you quantize the semantics, right? And then the second problem is, how do you store the semantic? And how do you define the similarity? And finally, is your solution generalized enough to different granularity, right? So those are the 4 fundamental problems. If you can solve all of them, then, at least from the research perspective, you are good to go, right? But there are a lot of engineering problems that we will see later. Okay, so let's just, there are a lot of topics about neural search, but I will stop here. I will go to the next session and tell you more about the DALL-E and diffusion, right? And so the DALL-E flow is, as I said, is creating images from text, is presented or proposed by OpenAI back in 2021, right? And this is the first generation of DALL-E. And then in the second generation is basically proposed this year. And they have better quality. And this is a very classic result that presented on their blog page, on their homepage of OpenAI. There's an astronaut riding a horse, in photorealistic style. So who understand how does it work, like roughly? Oh, that's why you are hired, right? So so basically there are a lot of interpretation of DALL-E flow, but it's actually not open sourced, right? So OpenAI never really opens these things to the people, right? So there's no source code, there's no pre-trained model. But let's say OpenAI writes their blog post very nicely, so people can reverse engineer from their blog posts and also from their recent publications. So it is not really a black box, but it's also not a white box. So it's kind of like in between, right? And because OpenAI also provides a lot of examples on their blog posts, so people can build their own models and using OpenAI's example as a kind of regression test. So there are a lot of YouTube videos which gives a very nice introduction about DALL-E flow, about the DALL-E model itself. So some of them are presented by some internet celebrity, like this guy, right? So this is not really the machine learning guy. I watch a lot of like a keyboard review from this guy, keyboard or like an iPhone review from this guy. But to fully understand DALL-E is actually not easy, right? So you need to at least know the three models, right? The BERT model, right, proposed by Google in 2018, right? And or people call it transformer. And then the another very important is VQVAE, right? Variational autoencoder, proposed by, I think it's also by Google or OpenAI. Yes, it's also by Google back in 2018. And then the CLIP model proposed by OpenAI in 2021. So these are the three pillars to build DALL-E, right? I mean, each one of them, I can have a 1 hour talk about each one of them. And to be honest, I also don't know every details of each model. But the BERT model is natural, is a language model that basically model the the language and can predict the next token using the attention mechanism, right? So this is the orange paper is called attention is what is all you need, right? And then there is a VQVAE, variational autoencoder paper, which is talking about how do you compress an image into a very small vectors and then reconstruct the image from this very small vectors, right? And finally, the most important thing is a CLIP model, which is basically cross modality, right? So CLIP is very exciting because all the other things like the BERT model and the VQVAE, right? It's all about single modality. BERT only works in natural language, right? It only works in text, right? And VQVAE only works in image, right? But the CLIP cross the image and text, right? So they build the relationship between the model, the relationship between the images and text. So there is a very nice open source package, developed by us. It's called CLIP as Service, which basically a wrapper on top of OpenAI CLIP, and then you can use it. It basically can do the embedding, reasoning, all this kind of task. So let's quickly go over the the OpenAI DALL-E model. This is actually the second generation of the DALL-E because there is a diffusion prior in between. All right. So the general idea is you have your input is a sentence, right? It's a text sentence, and then you use CLIP model to translate it into a vector, to represent it into a vector, right? And then you add a diffusion model to translate this, to map this text vectors to the image vectors, right? And finally, you use this kind of VQ-GAN model to decode this image vector back to the image, right? So that's a very on the very surface of this DALL-E model, right? So there are a lot of variants. For example, the first DALL-E model is kind of like this one, right? So without the diffusion, right? So you directly encode using a clip model to map this sentence into the text vectors and then directly decode the text vectors into the image. This is possible because the clip model is already cross-modality, right? So the image vectors and the text vectors are actually in the same vector representation space. So that's why it is possible. But researchers found out that, so among all these variants, all these combinations, the final one, so with the diffusion prior, actually worked the best, right? And that comes to the second part of this generative art. Generative, the theoretical part of this generative art is a diffusion. All right, who knows what is diffusion? Who have heard this term, like diffusion? Can anybody explain what is diffusion? Yeah, please.
It's a movement in physics, at least movement of particle by entity random.
Yes. So it's kind of like a equilibrium, right? So you reach your, like it's entropy, thermal physics, reach the equilibrium somehow, right? So the diffusion in machine learning is kind of like a kind of random process, right? So you start from pictures, right, on the right, on the right hand side, and then you start to add Gaussian noise to the pictures, right? In the end, after several steps, right, you get this picture, which is completely random noise. And then the diffusion model is trying to build a neural network that recover from the random noise back to the original image, right? So you intentionally add noise until it is not really readable to a human anymore, right? And then you use neural network to decode the image, to reconstruct the image step by step, and then back to the original image, and then minimize the loss between the, or minimize the difference between the original image and the reconstructed images. Right. Yeah, so that's the diffusion model. Right. So diffusion model can do a lot of very, fancy artwork, right? So this is one artwork I generated using disco diffusion. Right. You can also Google this term, disco diffusion. It's kind of like a very big diffusion model that trained on a lot of artwork. So it has a very nice image quality compared to DALL-E, right? This is another one. I think the text prompt is a satellite shooting laser beams to the Earth, right? So something like this. And this is some alien, I don't know. I forgot what the prompt is. But you can see the image quality and also the art style is more advanced compared to the DALL-E one. All right. Okay, so in the hands-on section, right? So we will actually see both. Right? So we provide you two models. One is a DALL-E model, one is a diffusion model, right? And then you can see the both on the both side. How are they different? In terms of the behavior, in terms of the result. So there are a couple of limitations of the diffusion model, but I will leave it to you, and you can figure it out by yourself. In general, diffusion model is much slower than DALL-E, right? Because if you look at this picture, so diffusion model is kind of like the old LSTM, right, or RNN, recurrent neural network. So you cannot really skip all the steps. So because it's kind of like a random process, you cannot really skip all the steps. So in terms of efficiency, it is much slower than DALL-E model. Okay, so there's some very short summary, comparison of DALL-E versus diffusion. One is fast, one is slow. So DALL-E gives a medium image quality, and diffusion gives you very high image quality. But one thing is very interesting is that I always found that diffusion model is not very good at generate reflection. Basically, you can ask the diffusion model to generate a balloon with reflection in the water, and then diffusion model will get confused, right? Because diffusion model only works locally, right? It's keep adding local noise or keep reconstruct from the local noise. So it doesn't consider the spatial relationship too much. So things like a mirror, reflection, all this very complicated spatial relationship will confuse diffusion model a lot. Okay, so that's kind of DALL-E and diffusion model. So now let's talk about Jina tech stack. Right? How is everything, related to Jina, to what we are going to use today? So as I said, we are the creator of neurosearch. We propose this term neurosearch, and then we provide all this, tech stacks that support people, allow developers to build their neurosearch solution end-to-endly, right? From prototyping to design a system, to deploy such system, to monitoring, to upscaling, right? And finally to analytics. Right? So today, the most important three projects that we are going to use is DocArray, Jina, and the Clipper service. Right. So I mean, it is very hard to to talk about the whole thing in one talk, right? So, but I will try to give you a very basic idea. What are the most important concept in Jina tech stack? So basically, there's three little guys: the document, the executor, and the flow. Right. So as long as you understand these three concepts, so you probably you get a good feeling of how Jina works. So to give you to show you the idea, right? So this is a minimum project, right? A minimum app written in Jina, right? So in the first line, you kind of from Jina imports the three concept, executor, document flow, and then you have a decorator, Python decorator called request, right? And then you build a class. The class has a very simple method is a foo, and then it just print whatever it receives. Right? And then you decorate this method with a request, this decorator, right? And then you build a flow, which only has one component in this flow. It's kind of like a pipeline or workflow, but only one component in this flow. It's basically your executor, right? And after the flow is built, you can use it as a file handler. You can open it with a with context manager and then post something to the flow. So the result is very predictable, right? And so it will open some service, all these kind of things, and then print the result for you. So that's basically Jina, right? So that's a very simple program written in Jina. But then you can see that we have covered the three concepts, three basic concepts in Jina. Right. So document in Jina can represent a lot of things, can represent multi-model data, can represent cross-model data. So executor is also very powerful. It's basically like a function, but it's kind of like a network function because you want to make it like a microservice. Right. The flow is kind of an orchestration layer on top of everything. Right. So we will talk about why, how this design is reasonable. But let's first go to the document, right? As I said, document in Jina is a fundamental concept in Jina. It is kind of like ND array in NumPy, right? Or tensor in TensorFlow. Is one of the very basic data type in Jina, right? So you can use document to represent a lot of things, especially in Jina, document is recurrent, right? So you can recurrently build documents, subdocuments, in two directions, right? Either vertically or horizontally. So this will help you to build up the to represent a very complicated nested structure from the real world, all right? So another thing is, another example I give it here is, you can also use document and data class to represent a multimodal object. For example, this card, right? This card where you have image, you have title, subtitle, you have author, timestamp. You can easily represent this card, multi-model card in document using the data class decorator. Right. So the executor can do a lot of things. It's basically like a function, but once you write something as an executor, the intention is always you want to scale it, right? You want to make it as work like a microservice instead of just a local function, right? And so you can do a lot of things like segmenting, pre-processing, embedding, storing, retrieving, filtering, sorting, ranking, all these kind of things, right? You can also use different packages, different framework like PyTorch, TensorFlow, Onyx, PyTorch Lightning, Fast AI, scikit-learn, all these kind of things, right? So finally, the flow is, as I said, it's kind of like an orchestration layer on top of everything, right? So you can build a very simple flow by adding, just write 2 adds, and this will gives you 2 empty executor, no ops, which basically doesn't do anything, and build a very linear flow, linear pipeline for your application, right? So you can imagine. So let's say this is embedding. The first executor is about embedding something, embedding images into vectors. The second executor is about storing the vectors in the database, right? So you can also add some parallelization or concurrency to the flow, right? So you can basically add, using needs this keyword to build some parallelization. There is also interparallelization. You can very easily scale an executor, right? So instead of doing all this multi-processing by yourself, you can easily just write parallel equals 3 or replicas equals 3, and this will build up, this will scale your executor into 3 replicas. Right? And the flow can be run either locally on your laptop, it could be run on remotely, or it could be run inside the Docker container, and the same as each executor, right? So for example, you can write an executor and then put into a GPU server, and then only remotely connect this GPU server via the host keywords. Or you can wrap this executor into a Docker container, right? And then use it in this way. Or you can use it in a remote Docker container, right? So the flow also provides a lot of web interface. So for example, I want to build a solution that serves REST API, serve HTTP request, right? Then you just write your protocol equals HTTP, that's it, right? Otherwise, by default, it supports gRPC, which is also a very great software developed by Google. And a WebSocket, is also a streaming protocol based on top of TCP, right? You can also decouple your flow into client and server architecture, right? So that's give you a very overview about, very shallow overview about how the Jina works, right? So if you ask me, like, why do we have all this concept? So I want to show you this graph, right? So those are the graph that explain the 7 layers when you build a neural search applications or neural search solution, such as DALL-E, right? Or DALL-E flow, right? So from the bottom, you have the network and the computation layer. On top of that, you have some data types, and this data must be transferred via the network. And then on top of that, you have your own logic. You have some runtime. This runtime could be Python, could be JIT compiler, this Numba, all these kind of things. And then on top of that, you want to wrap the runtime into a microservice. And finally, you want to use the orchestration like a Kubernetes, Docker Swarm to connect all the microservices together. And this serves as your final applications to the end user, right? So those are the 7 layers, you eventually will end up with when you build a neural search solution. So in Jina, we basically cover all the design patterns, all the caveats and pitfalls that you will meet when you build such solution, right? What is better is that we only we only expose the 3 layers to you, right? The data types, the logic, and finally the orchestration. So those are the 3 layers that you really have to care about. All the other things are hidden from you, right? So as a developer, you don't have to worry about them because Jina will take care all of this thing for you, right? And then if you observe this very closely, you will find that these 3 layers actually corresponds to 3 fundamental concepts that I was just talking about, right? So data types corresponds to the document, logic corresponds to the executor, and orchestration corresponds to the flow, right? So those are the, the mapping between those layers and our fundamental concept. So that's why I say after you master those, after you're mastering these 3 concepts, so you are good to go. You can build your own neural search solution. Okay, so one thing I want to spend a little bit time on, but this is also another very big topic, is cloud native. So Jina branded itself, or we branded itself as a cloud native neural search framework, right? So who knows what is cloud native? Oh, so can you name some like basic concepts in the cloud native? So what is considered as a cloud native?
Well, your application which runs only in clouds, like this levels like platform as service, it's on top of it. Application as service, as far as I remember. So you basically click buttons and your solution runs into cloud machines without your interference and configurations and orchestration and so on.
Okay. So any other like explanation on the cloud native? Okay, please.
You only expect something to run in the cloud and you don't build it for running.
I see. Okay, so here's like a multiple choice, right? So you can select a cloud native framework from those machine learning frameworks, right? A, TensorFlow, B, PyTorch, C, NumPy, D, scikit-learn, right? So who is cloud native? Yes?
I think a lot of them are trying to be, but I wouldn't say that.
Yeah, that's correct. So this is a trick question, and none of them are cloud native, right? So that's why you see how awesome Jina is, right? So we are trying to be cloud native from the first day, right? But what is exactly the cloud native, right? So I think this is a very, very, very important concept, or slice in cloud native. So basically, next time when people ask you, right, so when you do the interview, you just remember these 4 words, and then you probably get your job, right? So microservice is cloud native. So when we talk about cloud native applications, it must be microservice. It cannot be a monolith program, right? It cannot be a single process, single thread monolith program. It must involve microservice. And then secondly, it must involve Docker, container, right? All this virtualization or containerization, right? To build the isolated namespace to protect your source code, to make your source code immutable, it's more easily version control, and so on, right? Hot patching, all this kind of thing. Orchestration, of course, Kubernetes, Docker Swarm. So those are the 2 popular orchestration tools. People call Kubernetes as an operating system in the cloud, right? Which is also like a Google initiated, but later is, most of the users use Kubernetes on AWS, right? So that's kind of the the orchestration part, right? Nobody use Docker Swarm, by the way, right? Unless you are doing some local debugging that you use Docker Swarm, but usually in production people just go for Kubernetes, right? And the final component is observability, right? So that means you want to build some monitor, analytics, Grafana, all this kind of observability tools to monitor your service, to make sure that your service don't go, out of service, all these kind of things. Right? It's stable. It's you have you are not really under attack. All this kind of thing. So the question now is, why do we have to combine the neural search with cloud native? Why do we have to marry these two concepts together? Are we trying to invent something, invent some Frankenstein that nobody is going to appreciate, and we just dream that, it's going to be useful? Actually, no, right? So I will explain this into these three, into three arguments, right? The first argument is that if you think about neural search, right? So we will later talk about DALL-E flow and its implementation. And then if you think about neural search, even the simplest neural search, right? So imagine the image search, the fashion image search. You want to represent the fashion images into vectors, store the vectors, and later retrieve the vectors, and then return these images back to the user. It's not a monolith program. It is not a single task, right? So it seems that when you do the neural search, you at least are building two concurrent runtime. So one is for indexing, right? So for feeding some data, to store some data. One runtime is about query, right? About search, right? So after everything is encoded, is stored, you want to search, you want to retrieve from that, right? So it is never a single task. It is never a monolith program. It is not like you have the BERT model and then neural search is solved, right? It's not like that. So you need a database, you need a front end, you need a pre-processing, you need a post-processing, you need a ranking, aggregating, a lot of things, right? And then the idea of microservice perfectly fit into this scenario, right? So microservice is about, for each small task, you try to build it as independent as you can, right? And later you orchestrate all the microservice to accomplish a big task, right? So this is perfectly matching what we have in the neural search, right? And then the second problem is dependency. I remember like a lot of people, they try to get their hands dirty with AI, with DALL-E flow, with DALL-E, all this kind of thing. And then they spend the first 2 or 3 days by just install the CUDA driver, right? By just install all the TensorFlow, with the right version, and then this CUDA 11 doesn't match with the CUDA 7, or all this kind of thing. And then you kind of burn out. You say, oh, forget about it. I will go NFT, right? So I will go, I will go blockchain, right? So this is a huge blocker, right? This is a huge blocker. To be honest, like I also face these things, right? And the best part is, if you switch to another machine, you have to do these things again, right? So you install everything on your laptop, and then you come to the office, come to your university, and you have to do these things again, right? So you have to do these things for your girlfriend, for your classmates, for everybody, right? And then one day you found out, okay, enough is enough, right? So let's somehow freeze all the dependency, right? We know that, okay, so this even simple CNN, we need some CUDA driver, we need PyTorch, we need Hugging Face, we need to freeze all this dependency. Okay, so how about just make everything immutable, right? I just compile it once and it runs everywhere. So in neural search, as I said, so you have a lot of small tasks, right? Each one of the tasks is, involves a lot of deep learning, right? So that's why solving the dependency problem is a real headache. It's a real pain in the ass, right? You must solve it, right? So there is no other workaround. And then containerization provides a perfect solution to the dependency resolution, right? And finally, the neural search, the last one is a little bit hard to understand, because when you try to build a neural search, it is often not an end user. Let's say it is not an end user service, right? It's not like, oh, the search becomes an app, and then you sell it to your grandpa, grandma, and then they will just buy this app on App Store. It's not like that. The neural search is often an infrastructure. It's often a middleware. So it's not a consumer-facing application. It is just an infrastructure. And then you usually do the neural search in a backend team, and then you combine this, you work with some front end, you build an app on top of that. So for example, if I'm an e-commerce company, I sell a lot of clothes, right? So I have a recommendation system can be implemented by neural search with Jina. I have a search system, can be implemented by Jina. But then this search service or recommendation service, they don't work as an end user service alone, right? You have to wrap it into an app. You have to wrap this service into a search box, right? And then finally provide to the end user. So neural search is now the end user. It's not really consumer facing, right? It is mostly developer facing. You are trying to build a service, right, for the other developers to call, to invoke, right? So in that sense, I call neural search is often an infrastructure, right? So if it is an infrastructure, the first thing you want to be is to be stable, to be robust as possible, as much as possible, right? So then you need to build your observability, DevOps, CI/CD, all this kind of thing to make sure it is stable enough to serve a lot of traffic, to serve end users. Right? So that's basically the touching point. To justify this marriage is something reasonable, right? Okay, so what do we have? Okay, so we are about to go to the next section. So so now you can go to, if you have your laptop, so you can go to your open your laptop and check this DALL-E flow. And while you are checking, I will just explain the DALL-E flow from the server perspective. Right?
Maybe also somehow show the password again.
Yeah. Okay.
Someone come late didn't get it.
Okay. Okay. Okay, so is our GPU ready, like for the traffic?
Yeah, it's just the GPU server is receiving traffic from external.
But there is only one GPU, right? Like how many GPUs are we using in Berlin? Okay, that's fine. And then we have this 8 GPUs, right? Okay, so but keep testing. So I will still spend like 5 minutes on the DALL-E server part. So I will first explain this how the DALL-E flow is actually implemented. So DALL-E flow is actually a client server architecture, right? So it's implemented as a client server architecture. So you can go to GitHub Jina AI, Jina-AI /DALL-E-flow, and then make sure you give a star on this repository. Right, so that's our KPI, and that's how I track all these investors, and so I will first talk about this flow, right? So DALL-E flow, everything is summarized into this flow YAML file, right? So it's very small, but it's very easy to understand, right? So the flow YAML consists of 2 big parts. So one is the meta information about the flow, the port, the protocol, the web protocol that you are using. And then the second part is executors, right? So what is executor? Executor is a network function. It's kind of microservice functions in Python, right? And then the flow, basically this YAML file basically described the orchestration, how everything is connected, right? So we have a very nice visualization. So if you use Jina, you can use Jina flow.load_config, load this YAML file, and then do .plot, and then it will give you this very nice configuration. So I think right now we are using 4 replicas for the diffusion model, and only one replica for DALL-E, right? But this is because DALL-E itself, inside DALL-E, there is already a parallelization over all the GPUs, right? So this, by the way, this 4 is just outdated. Right now we have 8 GPUs for you to use, and so basically you can see your data flow, you know, according to this visualization, right? From top to down, right? So let's go over it, right? So from the top, your input, your query goes to the gateway, and then it parallelizing your input into 2 pathways. On the left-hand side, you have DALL-E model. On the right-hand side, you have diffusion model, right? And then, you know, all the computation, GPU, all this, you know, GPU heavy stuff, after everything is done, you have kind of reducer. It's basically reduce everything, merge everything into one result, right? So when you test with a notebook, you will find that, okay, so the right pathway give you 8 results, 8 images, and the left pathways give you 8 images. So in total, after the first step, you receive 16 images, generated images. And then there is upscaling, like a 4 or 5 upscalers, basically upscale your images from 256 by 256 to 1024, right, by 1024. And that's basically DALL-E flow. It's very simple, but as you can see, it involves different deep learning components, such as DALL-E, such as diffusion model, and there is also re-ranking in the middle as a bottleneck, and then there's upscaler. There is also database, the storage at the end, basically is our context system. All right, so you will see. Okay. So now we can start the second part, right? The hands-on section. All right. Just 2 minutes. Okay. So let's take a break, and also if you have a question now, then feel free to ask. All right. If you don't have questions, so basically you can start your preparation work by either scan this code, or go to, remember, go to DALL-E Flow, but don't go to the main branch. Go to the Tool workshop. Go to this Tool workshop branch, and then click on this Open in Colab. So we will use Google Colab, for our next section, right? So how do you make sure you are using the right collab? Because we have 2 collab. One is in the community version. It is for the outsiders. One is for particularly designed for this workshop, right? So if you open your Google Colab and then you see this graph, and then you see there's a Tool workshop. So it is a right collab, right? It is a right collab notebook. So make sure you open the right collab notebook, because otherwise you won't use the 8 GPU. You will use a very slow GPU that serves the community.
Right now, do you think later?
Maybe we can try to put the screen in there as well, the second screen, so that it's displayed correctly.
We want to put this screen as well,
Okay.
slideshow,
Yeah.
because it's a little bit hard.
It's change layouts, right?
Yeah.
Spotlight.
It's like only the chat how it works. I tried this, but maybe this display, but I'm not sure if I was pressed.
Wait.
也不知道怎么弄。
感觉好像 seems not possible because it's not changeable.
No.
There's no option. No, this is like how you looked at like for DALL-E.
Hmm.
Yeah, but should be fine. It's a little bit hard for people sitting on this.
Okay.
We can also make the voice bigger. I hope they can see us better. Yeah, then just leave it like this. Things should be fine.
Okay. Okay. Anyway. Hey. Yeah, I'm just yeah, sure.
Yeah. So hi, my name is
Yeah.
Ethan.
Hey.
So,
Nice to meet you.
hi. So I have actually several questions. One more regarding the architecture.
Yeah.
And others regarding more the social part.
Yeah.
So regarding the architecture, I was wondering. So basically, you are allowing a company basically to run their model.
Yeah. Not a model, but a pipeline, a workflow.
Yeah. So in this regard, so let's say that we have a pipeline that has I don't know several transformers down one after the other.
Yeah.
So is every transformer in their own container?
Yes.
Okay.
In the one container. You can also make them in the one container. That is also possible. That is purely decided by you. You can control the granularity of your execution.
Okay. And how does it work for the communication of gradients? So for forward and backward gradients, how does it work?
The thing is that this is not a training framework.
It's not a.
It's not
it's
a
an inference.
It's an inference framework.
Yeah.
So there is no gradient.
Okay. So there is only like the forward.
Yes.
Okay.
It is only about serving feed forwarding. It's not about back propagating.
Which I think makes parallelization much more easy.
Yeah.
I have a question about the architecture you have.
Yeah.
First, you feed it to DALL-E Maker.
Yeah.
Why do you do so? Like to show the Jina AI, or you could just feed it to the latent diffusion model.
Yeah, but it's purely for education purpose, right? Is to try to let you to feel like okay, so DALL-E gives this result, and then diffusion gives this result. Remember the philosophical question, like there are two best wrapper at work, right? So one is what is the limitation of this generative art, right? And so this basically, if you want to make it as an app, or like as a real service, yes, as a demo, you don't have to do this. But this is only for education purpose.
Okay, also to showcase the Jina AI.
To showcase that okay, so we can parallelize, we can do these two pathways in parallel.
Okay, just interesting.
Yeah.
Any opinion on momentum for the diffusion part? Like, I mean, when we create variations, we have a change.
Yeah.
Can we just add that up? Can I do that?
Yeah, you can do that. Yeah, I'm very, to be honest, I'm not an expert in this diffusion. I just learned it in 1 week. So I don't know too much about it. But if you want to improvise, you want to improve this, we are very welcome. We can even support you with 1 GPU. Right? If you want to really develop this as a really like DALL-E flow as a service, we are very welcome to support you.
Oh, really?
Yes.
Great.
Yeah.
Might come back.
Because we are also thinking about whether we want to really host it as a service, as a long-term service, like a mid-journey, right? Like a mid-journey.
Yeah, I'm working on a website right now. Like I started working on a Django website.
Yeah.
Because I think you could really do advertising and so on.
Yeah.
And then support it with that.
Yeah. So that's what I said. When you build something like a DALL-E flow, right, it is kind of like infrastructure. Right? Because we are mostly working on the infrastructure side, right? So it's not really consumer driven, right? So I mean, our company is not really consumer driven,
Yeah.
right? But if you want to build something like a DALL-E flow as an app, right? As a in the app store, we can support you. Right? We can support. We are welcome to have this. As you as the end user.
Yeah.
Yeah.
No, I already asked before, but
We can start.
Okay, just one question. So, do you want to ask something?
No, here's my colleague.
Okay, no, that doesn't matter much here. So, how do you monetize your services? Because so I guess everything is open source.
Yeah. Well, no, right now we don't. Right now we don't.
Yeah. So, but why are you getting money from funds and so on? Because they're interested that then they will use your services. Right?
Yes. So this is our in the last 2 years we're basically burning money from investors. Right? So we have a lot of money to burn, but in the future, you know, we are going for commercial open source software company. Right? So imagine MongoDB, right? Elastic. Right? So we're kind of going to that mode. Right? So you basically have a free open source server, open source that you can deploy by yourself, you can manage by yourself, or you can say, okay, so it's just too hard, right? So I want to deploy this on AWS, but I don't want to deploy it by myself because you have to start all these instances. I want a central place that is very optimized user experience, such as Elastic Cloud, such as MongoDB Cloud, right? So we will provide you kind of a subscription model, like our hosted service for you, right? So then you log into our cloud, you do everything on our cloud, and then by that time, then we will charge you.
Yeah, but you said from the very beginning that you try to be cloud native, and it means that for end user it won't be a problem to deploy it on their own infrastructure.
That's true. That's kind of the tricky part when you're running an open source software as a business, right? So you have to make sure that you cannot really implement everything into the community version. Otherwise, nobody will use your paid version.
Hello.
Right? And then in the meanwhile, you cannot abandon the community version because the community version gives you the adoption. Without adoption, without people recognizing you, you are nothing. Right? Then who will use your paid version? They
Guys,
don't even know your community version. Right? So that's the tricky
audible?
part. That's how
Can you
it's different. When you run open source
guys,
as a company versus when you
in
run
case
open source as a hobby person.
you already started running the notebook, I think we should.
Request some private needs.
Yes, but right now we try to standardize all the requests. We try to say, okay, so let's hold on for a minute, right? So we will provide you the standardized service, and everybody can, work in the same umbrella instead of providing kind of like a consultancy for each client because that won't scale.
Guys, in case you are already trying the notebook, try to refresh it because we added another server so that we can handle all this load. So just refresh the client and.
So I'm looking for my master thesis.
Yeah.
And also, if you need a socket, here
sorry,
are,
what on that?
I don't know, about 10 sockets, so you can sit in front of you and use them.
Art generation.
For the laptops.
Like DALL-E, something like that.
You want to work your master thesis with us?
Why not?
Yeah, sure. Like, so we can think about, right? We can think about because generative art is just one, one direction we have. Okay, so let's get started. Otherwise, we don't have. Yeah, let's get started.
I was born there, but I lived for 6 years in Germany. Yeah.
Okay. You can talk about this one. So you just make sure that you install everything and then go to step by step. Refresh? Okay.
Yeah, also call them here. So I think we're about to start the second part.
Okay, guys. We need to start. Where's my mic? Okay. Okay, thank you. Okay, guys. I see fewer people here, so it's good for GPU, right? Okay. So anyway, so make sure that you see on top. So if you go scroll on the top, make sure you see this picture, right? So DALL-E Flow, and then you see this Tomb Workshop version, right? So this is the right version. If you are not in the right version, go to GitHub DALL-E Flow, switch the branch to Tomb Workshop, Tomb minus Workshop, and then there you click Open in Colab. So you will find this version, right? So make sure that everybody is on the same page, and then we are opening this version, and then I will hand over the microphone to my colleague Aladdin, and he will guide you to every part of this notebook and then generate one artwork together, right? And then you can improvise. You can go crazy, go nuts, right? And yeah.
Hello, everyone. I'm Aladdin, software engineer at Jina AI. And in this workshop, we will present DALL-E Flow. Yes, so in case some of you already started running the notebook, since I've been in the past hour trying to have another server to handle this load, I added this line here so that you can support the server. So try to refresh the client page so that you access the other server. So yeah, the first step, let's try to install Jina. And here already everything is installed. And basically, like we noticed a lot of people are joining, so we wanted to increase capacity in 1 hour. Don't do this load balancing for applications. Yeah, so basically we'll choose one of the servers, and here we'll use the initial one. And the first step of using DALL-E Flow is to write a prompt. And basically, the model will use this prompt in order to generate an image. And here we have some hints and suggestions to help you engineer your prompt to help the model. Okay, so here our prompt says an oil painting of a humanoid robot planning chess in the style of Matisse. And yes, the second step would be to send this prompt to the server. So we have two models that will generate images for us. We have diffusion and we have DALL-E. Each one will create 8 images. So we should have 16 in total. And I guess this might take some time now, I guess, since our servers are already received some requests. So let's just wait and hope we can find a spot with you in our servers.
Take a photo. We have 10 GDS, 11 at least.
Yeah, not even enough.
Because like some GPUs actually do support multitasking. So basically having some part of the resource of the GPU assigned to multi-tenancy. So basically client, which is what we are having now. So now we multiple users, so multiple processes to work with GPU. No, on the same GPU shared users. Okay. Because some GPU, it's a new thing from so I don't know if it's still like doing some things. Okay. Or do you actually handle it, like, or do you just queue every request after this? So basically, what we do right now is we have yeah. We have 4 replicas which use the remaining GPU devices. So each process occupies 1 GPU device. And actually, yeah, okay, so then it's already, if you take a look, it's like Already 100%.
Sorry?
Yeah.
There are also questions in the chat, and you can answer them by speaking to the microphone,
Okay.
so everybody will hear you.
I missed it.
Oh, the challenge. Okay. So let's first go to like make sure this step. I think it's like
I think we shouldn't show them this script before running it ourselves.
no, but people anyway have to hit this block. So maybe we can open the this one. So we can open the no, the tune workshop. Right? So let's look at the what we have. So we already have some submissions. So those are the lucky ones that like bypass the heavy traffic. They probably start earlier, like early bird gets a worm, right? And then we already have some submissions here. So you don't need to submit your artwork manually. So after the last step, right? So when you do the upscaling part, right? It automatically submit to this contest dashboard. Right? So you don't have to manually submit anything. And there is also like if you submit your work without adding your author, adding the author name, right? Why there's my Han Xiao ruling the world with Picasso? Okay, so from anonymous, right? And so by the way, yeah, this is nice, Melina, right? So she's very nice. She know how to add the author name, because this author name is very important. We will give you a word based on this name, right? Otherwise, you have to remember, you have to claim, right? The artwork is created by you, right? Okay, so let's see. Oh, it's still like running.
We can kill the process and start again so that we can get the spot for us.
No, I don't think it's queuing, right? It's queuing.
It takes time.
It takes time.
Yeah, so it looks like we are generating a lot of images already, and the organizer cannot run his notebook. So maybe we should assume that it's running fine. Okay, yeah. Since I guess most of you saw the results. So basically what this cell will print is 16 images. And yeah, you get to choose one of them. Here we are using document array API to select one of the images and display them. Unfortunately, we cannot display. And then in the next step is to refine. So we select one image and we refine it with diffusion, glide 3 model. And okay, what is it saying? It's in Chinese.
It's in Chinese. Oh, I failed.
Okay, now you see Han is not a robot.
Okay.
Yeah, so after selecting one image, we send it to the server for diffusion. So basically, this will modify a bit our image. And yeah, we get 9 images in total. And we get to choose one of them for the final upscaling. So upscaler is a model that will receive an image and return you a high quality version of that image. And yeah, in the last upscale step, this will submit your final document to our system, our contest system. But yeah, here we want you to set your name so that we can see that you have submitted this image, and that it does show in our dashboard. And yeah, basically you need to uncomment this line and put your name. Again, here we are using the document array API, which has this tags attribute. At the end, we display the image that we have generated in high quality, and you should be able to see it in this dashboard. And yeah, you can find the link over here to workshop.jina.ai. And we want you guys to check the artwork that you have generated and put your votes. And let's get the best artwork. But sure, we need your author name so that we verify it's you. Yeah, so we have one question, leak one, who said, is it possible to discuss later the limitations and challenges of neural search? I guess that's fine. We will do that later. And the second question is, now let's submit the selected candidates to the server. For diffusion, we have a block and value error. I guess maybe you run the script too early and the server was down, maybe, I would say. Maybe try to rerun. And remember that our server right now is overloaded and we have 11 GPU devices at 100% capacity. So we just have to wait, like it's just capacity, that's it.
We haven't thought about adding different, like combining another functionality like background. Yeah, like you guys knew the artwork and so on, so that it gets useful.
The thing is that we are infrastructure. We don't do consumer business. But we are very eager, we are very happy to support. Somebody make it like a full app. Because when you provide scalability all the time, then
Okay, finally we got a result. And yeah, so the next step is to display. Here we chose the third one. Yeah, third one. And we go to the next step. Now we have to wait again, I guess.
So another trick is that you can reset the number of images that we have here, right? So by default it's 9, right? And also here you can see 9 images. Here, so you give 9 image on where is this? This is oh yes, you give 8 images, right? But then it returns 60 images in total. So here it is because it is running 2 pathways, right? Remember, one on the right, we have DALL-E. On the left-hand side, we have diffusion model. So each pathway gives you 8 images, and then in total, it returns you 16 images, right? So in this result, I'm presenting, so you cannot really see the difference between DALL-E and diffusion model. So this is just a, given this prompt, you cannot really see the style difference. So all of them looks like, it's produced by single model, right? But don't let this observation misleading you, right? Don't let it mislead you, right? If you try another prompt, you probably observe that the first 8 images in the first 2 rows has very different style versus the third row and the fourth row. So you can notice that, okay, so this clearly is generated by 2 different kind of models, right? One is based on DALL-E, the other based on diffusion, all these thermal physics things, right? And yeah.
So when the second step completed, so remember we chose the picture over here and we sent it to diffusion, and diffusion will modify this slightly and give us 9 other images. So here we can go to the final step. Let's first select one of the images, and here I like, let's say for example, I like number 2, so I will choose it and I will display the image. So here notice that every object that we deal with is a document object from DocArray, and DocArray offers data structures that support neural search operations, basically all the multimodalities and data types that you need for your application. And we give also methods like this display method to help you play and visualize your data. So after selecting one image, we submit it to the last step, which is upscaler. And at the same time, this will submit our image to the contest system. So here I will write my name. And yeah, let's submit this. So again, as I said, all objects that we deal with here are coming from the DocArray library, and even the interfacing with the server is done through DocArray, which gives you an easy API to interact with neural search applications. And so check our repository and feel free to try it out. Yeah, so our image was sent to the server, and I think now we can see my image over here. So please give it a vote, guys.
All right, so we see some submissions, and so some of you may encounter the the traffic problem, or is waiting a lot of time. But this is we kind of predicted already, because this shows you that even today, right, when we look at DALL-E flow, when we look at DALL-E model, diffusion model, even generating 256 by 256 image is very time consuming, right? You need a lot of GPU, and to be honest, like we can share some of the some of our screenshot on the workload. So it's actually pretty like so you can see all the GPUs are using, right? So there, okay, so there's a, okay, it's not like a, okay, so it's not, no, we only share like we only present one window, right? So we can present the entire screen. So you can see, yeah, so you can see all the GPUs are heavily running, and there is no like a free slot. So right now we're using 11 GPUs, right? For this amount of traffic. So you yourself can give an estimation, right? So you want to build a service, right? DALL-E app, right? So you want to build an app, right? Then how many GPU do you need, right, for building such app, for serving to make it like usable to the users. No. So right now, if you compare to human, how many energy do we need to create an artwork, right? Probably just some alcohol, right? Some beer, right? So that would be enough, right? So in that sense, human is still more cost efficient, right? So there are also a couple of tricks that you can use. So the first thing I want to talk about is the skip rate, right? So in the second step, in the diffusion model, so you see there's a very mystery parameter called skip rate, right? Skip underscore rate. So skip rate basically represents the amount of, how much do you want to keep your original image, right? If you set the skip rate to very high, by the way, the maximum of the skip rate is 1.0. So the upper bound is 1.0, and the lower bound of the skip rate is 0, right? So it's a value between 0 to 1, right? If you set the skip rate to 1, then diffusion doesn't do anything, right? There is no improvise over your image. It basically returns the original image to you, right? What is most interesting is that if you set skip rate to 0, then it basically roll back to the first step where you start from a text prompt only, right? So you can basically imagine the diffusion works a little bit different versus DALL-E, right? So in the DALL-E, you always start with a text prompt. But in the diffusion, there is a parameter called skip rate, where you can control your initialization point, initialization seed of your diffusion model to respect more on the text prompt or to respect more on the image, right? So this is controlled by the skip rate. When we set skip rate to 0, it fully respects the text prompt and then ignore all the image information, right? If you set skip rate to 1, it is faster because it doesn't do anything, right? It fully respects your image, right? So here by default, I give you the number of 0.6, which is a sweet point where you kind of respect the original image, but in the meanwhile, did add a little bit improvise on top of that, right? So you can see the general big picture is more or less the same, but the eye, change from one eye to two eyes. This kind of like the chest is also a little bit different, but it's not so dramatic, right? If you want this to be dramatic, you can lower down the skip rate, right? But that also means it takes longer time, right? There is also, sorry, there is also another thing that you can check if you are out of your, you're kind of out of your creativity. You can check how to write good prompt. So there is a very nice documentation, basically summarize all the prompt trick that you can use, right? So you can add all this cyberpunk to give cyberpunk style. So to me, this is very nice, right? So this is kind of like another level of domain-specific language, right? It's kind of another programming language. So imagine you want to generate artwork, right? But instead of write it in Python, you have to write in a very special natural language, right? So this natural language is not really natural, although it looks like natural, but it's just a bunch of keywords that combine together, right? You like add those artist name, as this pencil drawing, wood block printing, mart printing, child's drawing, all these kind of things. So you can try to add those keywords into your text prompt and observe the difference, right? And there are also some other tricks like speak in positives, avoid negatives. So those are the, those are kind of the lessons we learn from the language model, right? From the clip, from the BERT model, that usually BERT works pretty well if you state everything in a positive manner instead of using double negative, right? Which only human understand, then bird will get confused, right? Yeah, so there are a lot of things that you can check here. Another very useful resources you can check. So this is what I just summarized from Clip, from OpenAI Clip, the source code of the Clip. So they actually, so where are all these templates come from? They actually come from the training data of OpenAI Clip model, right? So those are the image annotations that you use to train the Clip, to train the cross-modality model between text and images. So that means those templates already exist in the training data. So when you use it again during the inference time, of course, it will perform better because it is kind of overfit to the training data, right? So the model has already observed, has seen this thing, has seen this pattern, this sentence in the training data, right? So the model knows what to do, right? If you improvise yourself, the word is probably not directly represented or directly appeared in the training data. Therefore, the model could give you suboptimal performance, right? So you can look at all this template and check what you want. Yeah. So we have quite some artwork already here, right? So let's make it like a full screen. Where is the full screen? Okay. So make sure you scroll down because by default is sorted by the vote, by the number of votes. So if you like some of the artwork, make sure you give a thumb up, right? So especially those at the bottom, So if you are like very frustrated by the traffic, so you can think about the the 2 best rapper award. So let me remind you, the first question is, what is the limitation of the current generative art, right? Can you present some limitation? Can you summarize it very nicely, right? So this is where is it? Okay, this is the best rapper, right? Point out the limitation of the generative art, right? And the second is more philosophical questions. You can let's talk about, is generative art means an end to amateur artist, right? Should you like convince your girlfriend to give up their art degree, or after this workshop, or what do you want to do, right? So let's, if you are you cannot use the notebook right now to also think about these things, right? Yeah, please.
Can you hear me?
Yeah.
If we have time-bounded systems, can we improve the importance of DALL-E and deprioritize the diffusion so that we may get less quality images, yet we achieve the task in a shorter manner? And also, you said that the DALL-E has a better understanding of shades and the shading against the diffusion. So can we utilize this so that if our targeted image of our prompt has more meanings with shadows, can we transfer this information as a accurate output?
Yeah. So, so to answer the question is, so the question is basically asking, yeah, diffusion is good at quality, but it's very shabby or very stupid on understanding all this reflection, mirror, spatial relationship. Can we combine the best part of two worlds together to build one powerful model? And this is exactly DALL-E 2, right? So what we are using right now in the notebook is the first version of DALL-E, right? So it's basically what the OpenAI released last year, right? It's kind of like the very first version of DALL-E, right? DALL-E 2 basically combines the diffusion into DALL-E model so that the artwork generated by DALL-E 2 is very high quality. It also understands the spatial relationship, all these kind of things, right? And so, but right now, DALL-E, there is no open source version of DALL-E 2, or there is one, and people still developing that. It's written in PyTorch, but it's very, very computational demanding, right? It's very, very computational demanding. So as you can see, even running DALL-E 1, right, with diffusion, and then to serve this room, not very happily, right? So we already have to spend 11 GPUs, right? So is there any questions? So if you have, so I can also take this time to answer your questions. Yeah, please.
DALL-E is not very good with text and images. Like if you say a store that displays this specific phrase, how good is your implementation with that?
Yes, so DALL-E is not very good at representing text, right? So this is also there is, I don't know how many of you like use Twitter, right? So it's very social app, right? So on Twitter recently there is a very viral internet thread talking about the computer, the artificial intelligence inventing their own language, right? So I did the same experiment before running this workshop, so I can show this to you. It's very interesting. I send this in our random channel. So I tried to prompt a paper with a word that described Apple, written in the language invented by AI, right? And this is DALL-E flow gives you, right? So this is let me repeat, the prompt is a paper with a word to describe Apple, written in the language invented by AI. Okay, so these are the three symbols, right? And then now I just found these three symbols in Unicode, right? I found these three symbols and then use this as a text prompt. And this is what I get. Yes. So DALL-E does, so artificial intelligence is not secretly developing another language, right? So it doesn't make sense, right? So, but this is very, very funny examples. So look at, we have three emojis here, right? So three, so basically show that it's very funny. Right? Okay, but this is a very interesting question. Like you can check out, right? So I remember I was also like asked by some people, like they ask why is this word, the word, the text, generated by those diffusion or DALL-E model, why it looks so weird? It doesn't look like an English alphabet. It also doesn't, of course, doesn't look Chinese alphabet, Chinese characters, right? So why it looks so weird and why it does so bad on this? So my argument is that it is only bad to human, right? If you ask a cat or dog to see the things that you generated, they probably think, oh, it makes sense. It's a human, you know, it's a human things, right? It's a human language things. So to them, it looks like the right alphabet, right? So to them, if I ask a cat about these things, you know, it's probably they say, oh, it's just a human thing. I mean, if cat can say something, right? And but to human, of course, it doesn't make sense, right? But I think it's also like you can also try this, and then you will find out that in general, diffusion model is actually pretty good at generating text, right? A text inside image, right? Sometimes you found there is a diffusion model. Sometimes even found a shortcut to generate images. I remember there is one example in our database, which is the prompt is a very beautiful scene that one could hardly imagine, right? And then the generated image is basically literally this sentence, then written in a text, right? Written on a paper. Right? So the model is successfully finding the shortcut, but just plotting the text onto the image instead of really trying to figure out all this, what the human means, right? Okay, so let's go back and see what we have here. So if you found your favorite one, please vote, because TikTok, we are going to. This is nice. Like I wonder what is the problem here. Like I think there is also some network problem, so it's not really fully downloaded for some images. But I'm curious what is the problem is, because this looks like you directly retrieve the the training image somehow. Or did you learn the DocArray API like deep enough that you somehow like upload your own pictures? That is also possible, right? So I think we have some network issues here, right? Hi, Doggy, can you check this website is still working? Because I have a feeling that a lot of requests. Okay, I see. Okay, now this website is also down, right? Yeah, I guess it's because it's receiving a lot of requests. We didn't stress test this one, right? We didn't stress test this front end. So that's why you need Jina AI, right? So it's like a full stack, end to end. So in order to to recap, in order to build a fully neural search solution, you need the stable front end, stable back end, and it is not easy, right? Yes. Yes.
Okay, a bit disturbed by everyone's quiet now. So say I want to found a startup and I want to use Jina AI. How much would it cost me for like some basic scale to start with?
Nothing.
Nothing. Okay, but,
right, so what we have is we have a lot of open source projects that are open source framework, open source tools. You basically start from DocArray to build a prototype, right? And then you use Jina to make it as a service to scale it up, using replicas, sharding, all these kind of things. And then we also have a very nice, basically it's kind of model zoo or hub, where you can find a lot of like a reusable building blocks. So you can go to hub.jina.ai. So here you found there is a clip image encoder, indexer, transformer, all this kind of thing, PQ light, audio clip, all this kind of thing. You can play the sandbox. Okay, so here, you can play it online. It's a kind of like a sandbox, online service. You can generate your own code, and then here is also like a README text. It's basically like microservice collection, right? So all of them, each of them is microservice, and then you can build your own service on top of that.
But how do you monetize Jina AI then?
Right now, we are just burning money, right?
Ah.
Like we're burning money like crazy, like right. So right now we are just burning investors' money, right? So and but to be honest, that's how like a startup works, right? So that's how like a but seriously, that's how the commercial open source software works, right? So imagine, we are commercial, one of the commercial open source software company, and people call us COSS, cost company, right? So in the cost company, right? So in the first couple of years, you are now trying to monetize. You are now trying to build a SaaS. You are now trying to build a paywall. You're now trying to do all this kind of credit card charging, all this kind of things. In the first couple of years, the most important thing is the adoption. It's whether developers recognize you, whether the community recognize you. I mean, we are not the only one, right? So we are not the only cost company. The most oldest cost company is Red Hat, right? Red Hat. You know, they kind of like they try to maintain the Linux, you know, with all this Linux distribution, and they are also acquired first by IBM and then Microsoft, and then you know all these kind of things. And we also have Elastic, right, which is the mother company behind Elasticsearch, right? We have MongoDB, we have Databricks, we have GitLab. By the way, GitHub is actually not a commercial open source software company. The difference between GitLab and GitHub is that GitHub is basically like a social platform. It's like a Facebook, but for developers, right? So GitLab is really open source everything, infrastructure to the community. So basically you can fork GitLab and then start your own GitLab. But on GitHub, you cannot really fork GitHub and start your own GitHub. Right? So that's the difference, right? So that's why we say, although GitHub is really like a lot of developers, you know, go to GitHub using GitHub, but it's not an open source company, right? It has some open source things, but let's say it is on the corner, so imagine, so back to the monetization or all the strategies here, right? So when we talk about open source, there are two kind of, you know, we always talk about open core. It's kind of like a business model that you want to build for the open source company, right? So the open core business model, you can imagine it is like you're serving a pizza, right? So you have a party, right? So you serve a pizza, you know, you invite people to eat your pizza for free, right? And some people are very generous. I say that, okay, so there is a, you know, salami, mozzarella on the pizza, you can eat this part for free. And some people are very greedy, say that, you know, you see the crust on the pizza, on the edge of the pizza, you can only eat this part for free, right? So this basically becomes two different models, business models, right? So let's go back to the Red Hat example, to the Linux, right? So Linux is basically not trying to monetize anything, right? It's trying to sell the whole operating, try to give away the whole operating system. The only thing that Linux or Red Hat is monetizing is basically the professional training, the swags, the t-shirts, right? Selling some training course about using Linux. But the operating system is for free. It's completely for free. So this is very, very generous open core business model. We call it very thin business model, thin open core. And there is also fat open core. And so basically you try to protect everything to yourself and only open source, you know, something that not really related to your business model, right? So for example, what GitHub is doing, right? So that basically explains the how do you run a commercial open source software company, right? First step, first couple of years, it's not about making money. It's about convincing developers this mindset, about convincing developers to use your software. So you can also imagine this is a pre-sale procedure, right? So you try to pre-sell a mindset without charging any people's money, right? So, but you have to be convinced. You have to be convinced that, okay, so Jina is a go-to framework, is a go-to tools for building such software, right? So once you have this mindset in your mind, right? And then the next step is we provide something on top of that. We provide hosting, we provide auto-scaling, we provide observability, we provide monitoring, we provide kind of like a Google Analytics on top of that. So those are the value-adding service that you will use when you really try to do Gina seriously, when you really try to use Gina seriously in production. You must require observability. You must require analytics, search analytics, right? All these kind of things. So those are the monetization point. So the framework, what you see right now here, is not monetizing, right? It's not that easy, right? So it's not that, it's not that shallow. So the monetization always comes after, right? When you have all the infrastructure set up, and then you go to the next step, and then there we have the monetization. Yeah, please.
Can you guys hear me now? Okay. So the question was about ethics and how biased DALE and DALE-2 is. I just ran now here and actually crashed, but I typed CEO and what it generated was actually a white male. So how do you think we can solve this problem? Because what happens with these models, they just kind of emphasize the embodied social biases that we currently have.
Yes.
How do you think this problem can be solved?
Yes. So social bias, ethicness of this generative art is the main reason that why OpenAI does not open sources, right? It's always serve as a paid service to you, right? Where Google basically also recently released this image gen, right? It's image generation model. But as you can see, they also do not open this API completely, right? So you have to join the waiting list, wait for a couple of months, and then you click on the agreement to make sure that you are not, suing them for all these kind of things, right? But this is the main cause of such problem is the data, is the training data, it's the training because how this DALL-E model is trained, because this is basically like OpenAI write a spider, crawling all the images on the web from Wikipedia, from all the images and the open website, and then build this huge amount of data, parallel data, right? Image text pairs, right? And then by nature, this image text pair is biased, right? There's unless there is you impose some certain mechanism to avoid this bias. If you train the model from scratch very naturally, just follow all the mathematical equations, just follow the neural network. I mean, I always believe that the machine learning researchers, when they train such models, they are not intended to make it biased, right? It is always unintentional, right? In the end, they found out, oh, this looks like bad, looks like a political incorrect, generative art. So let's fix it, right? So usually when you read OpenAI's paper, right, when you read their blog post, at the end, they always talk about ethicness. They always talk about the limitation of the model. And the first section is always about the bias, the social bias of the model, right? But interestingly, right, so we can, there is also a project that leverage these things and then doing good, right? So I wouldn't see this very pessimistically, because first of all, it is a problem, to be honest, but and it is also very hard to solve. I want to show you one example. So you can, I'm now trying to promote this repository, but I just found this repository very, very interesting, right? So let me check.
I will quickly interrupt this. I think this would be then the last question so that you guys can go and network outside.
Yeah. So, oh yeah, we have to do the contest. We have to, do the lucky draw. Right?
Because we're already over time, so it would be great wrapping things.
So there is what is this called? Kuber Disco diffusion, RDX Pascal. Okay, so I don't have first order model. I think there is a GitHub repository basically using this clip model to detect social bias, And I found this very, very inspiring, but I cannot really, oh, this one, DALL-E eval, right? It's the DALL-E eval. So this is not created by us. This is basically, they build a framework. So this guy, I guess, is some PhD students and working on the AI ethic parts. And then there's a paper about DALL-E eval. There's probing the reasoning skills and social bias to the text-to-image generative transformers, right? So as you can see, they basically generated the image and then using another cascading model, right? Another kind of like a model to detect whether this image is kind of social biased, right? And this is based on some prompt trick in the clip by using clip model, right? So for example, you can input a text prompt called a photo of lawyer and a white male, right? So very, very cliche, you know, this kind of social bias, right? And then you can add another models on top of that and detect whether this generated image is a male and a white, right? And then based on this result, you can re-rank this. You can re-rank. You can generate 60 of them, right? And probably one of them is black women, right? Or one of them is, you know, is not white male, right? You can use this trick to re-rank all the generative work art, right? And then re-rank this so that the final, the top 10 result is kind of like a very diversified and, it is very, it is kind of like a correct, right? So what they use here is actually very, very simple. So if you use a clip as service, you can do this immediately, right? So they basically build kind of a classifier, right? So a very, very simple classifier. So let me zoom in a little bit. So the first is a photo of male, and then second is a photo of female. And then there is a race. It's basically a photo of white person, a photo of black person, an Asian person, Hispanic persons, right? And then they ask the clip model to rank such thing, right? So you can easily do such thing via clip as service. So here we also give an example. So you can just go home and test this test it by yourself. So for example, we just randomly grab some images from some photo stock, right? And then we ask. We also input a match, like two sentences. One is there is a woman in the photo, and then second is there is a man in the photo. And then you ask the clip model which has a higher probability. So surprisingly, actually this is wrong, right? So there's actually from the background you can see it's most likely a man but not a woman. But this is somehow something wrong. But you can also use a clip model to do certain reasoning. For example, the spatial relations, right? So here you can input 4 sentences, like describing the blue car and red car, the spatial relationship between these two cars, and then you can ask the model to rank it. And in this case, it is actually ranked correctly, right? And finally, the model is also capable of simple counting, right? So you can ask how many berries in these photos. All right, so you can just build a list of prompts. There is 1 berry in the photo. There are 2 berries in the photo. There are 3 berries in the photo, and ask the model to re-rank this, right? And it gives you kind of the right answer, right? The 3 berries and 4 berries are ranked on top, right? So you can use this, right? I mean, DALL-E itself is generative. It's usually unsupervised. There is no supervision afterward, but you can use clip model to build another layer of supervision, right? To make sure that it is ethically correct, right? Okay, so I think we have another last question, right? So
no, it was the last question. I'm sorry, because you're over time, we can just go straight to the competition.
Okay, so everybody votes already, right? So then this is a final decision, right? So the first one is Florian Hope. Who is Florian Hope? Okay. Oh no, you're the second one now. Okay. No, but okay. So the Florian Dunhauser. Oh, cool. Yeah, stand up. And then the Florian Hope. Florian Hope, the second one. Yeah, yeah. Okay, so we will give you a swag. So we have prepared already, right? So it's basically the the full suit, the full stack of our swag, right? So like including a very nice bag. And then the third one is Simon N. Who? Oh, come here. The third one, Garen. Yeah, come. So, oh, it's your. Oh, okay. So how do I pronounce your name? Yahini. Okay, come. Grab something. And then we have. So this is already 5. And then Wu Jin. Do we have Wu Jin? Okay, cool. Oh, by the way, we should really let them to explain their art, right? Explain what is their feeling when you create this artwork, right? So, like, but save it for your blog, right? So save it for your blog.
Can we take some photos
Okay,
of the winners as
multiverse
well,
is
please?
real.
A little later. I'm sorry.
Okay, and the next one is Han Xiao is ruling the world in the Picasso style, right? So this is I guess who is doing that? Oh, cool. Then come. I don't know how this is me ruling the world. Okay, so the next one is definitely trolling, right? So it's somehow figure out all this API, right? It's very smart, and is you are also hired, whoever it is. Like, can you show me? Oh, cool. Let's stand up. Yeah, kudos. Come here. Come here. And then the next one, I think we have 1, 2, 3, 4, 5, 6, and then we only have 2 left. Should I refresh the page because now? Should I refresh the page? Okay, so we don't suffer. The realistic photo of the monkey flexing is biceps. The cardin, yeah. Okay, a realistic photo of group of aliens surrounding the Earth. Who is that? The same one? No?
I'm virtual. I'm not on site.
Oh, you're not on site. Okay.
We have only one.
Oh, we have only one. Okay. Do we have another? Okay.
We can maybe take the.
Okay. Then we will. Okay. So. Okay. We will. So can you keep the address? Can you send the address to the?
Yeah. So can you maybe send your address to our GDSC email? You can find our email on our website. So it's DSC.
Yeah. Sure.
Munich.
All right. So we only have one left, and the final one because we plan to have 2 best rappers, but apparently like we can only afford 1, right? So any volunteers to present these 2 questions together? First, what is the limitation of the current generative art? Second, is generative art make amateur artists obsolete, right? Anyone else? I want like Yes, but unfortunately we cannot. We can have them, but we can only like have we can only ship the award to them. Yeah. Okay, so we have 3. Okay, so how do I do this? Like Okay, so maybe we give that to the. Is that a lady or like a? I'm not. Oh, you're not a lady. Okay, then. Okay, so first come. Like, okay, so first come first serve. Yeah, you. Yeah.
Okay, can you hear me? So as to limitations, I mean, I played around. It has a lot of problems with compositionality. It's like inputting horse riding an astronaut is same as like astronaut riding a horse, and then generating some text or some like more difficult textures. But it's not problem with just this model, I guess. DALL-E 2 has also some limitations with this compositionality, and there's some like school of thoughts that scaling works in this case, but it's kind of different debate. And the second question, the generative art, does it mean and to amateur artists? For amateur, maybe yes, but uh, but I would say that it kind of helped them. We can design a human in the loop system so they can draw their like amateur art, and then they can ask these models to make them better, or I don't know, to generate different kinds of. So we can kind of integrate it to the human in the loop. Then yeah, I won't take much of time.
All right, cool. Okay, so we give the last reward to this guy, and so whoever want to express their feeling about all these two questions, we still have some magnet. There's with a magnet. We know. Running out of time. Okay.
Driver are with the same range, and you miss DocArray. Like in the generation competition, there are like two other images which have the 7 likes, and you just ignore them.
Oh, really?
Yeah.
Okay. So which one is this? Like this one?
There are 7. Yeah.
Oh, but this one is from the online. It's from online.
Yeah, but there are 2 other 7 next to them.
Oh, okay. Yes. They're like a 4 7s. They're tied together.
Yeah.
Well, I guess somehow this is ranked on the top for some reason. Like I'm like it's just like I think it's okay. So right now we can only do this. Right? So let's design better like a contest system. Right? Okay.
This is first one. Like when you
So how about this for whoever like the 7s that we have, like if you are in this room, please leave your email address and also like the home address, so we can post you, we can email you, or we can mail these swags to you. Okay. All right, so it seems like we are out of time and they are not very happy, like all the delays. And thanks a lot for this session, and I hope you learned something.
Can we quickly switch back to the slides?
Yeah, okay. So we still have
I will just promote some of the upcoming events, and then you can go networking. I'm sorry.
Yeah.
So the next event we're having is a blockchain event. It's a virtual one, so you can scan the QR code and then come there if you're interested. And we have some spoilers for next upcoming events. First of all, this is the EdgeX event from NetLight, which is tomorrow. If some of you are going there and you want to go as a DC community, you can just go to our Slack, and there are some instructions where we meet and stuff like that. So if you're interested. And there's still some tickets left. The next on-site event we have is a cloud and DevOps workshop with NetLight. And the next event is, again, Introduction to Quantum AI. This is a virtual one. And we also have a competition, which is a CTF, a Capture the Flag. It will be most probably on the 1st of July. We have not yet posted that, but if you want to get some notifications, just scan a QR code, join our community to get the newsletter, and you will be notified about it for sure. And yeah, here are some of our social media accounts. So again, join them to get more notifications about the events. And that's it for the event. Thanks a lot for coming today. Yeah, thank you.
All right. So we found out we also have like about 20 of these stickers, and there are also like 15 of magnets. So if you want, we will put that outside. And this is a very limited version. And so make sure you get them, and also give a star on GitHub, right? I will talk to the investors and secure our next round, right?
Also, if you want to go, please come up to me or Liangda, because you need to be guided down. You're not allowed to move around to the Google building by yourself. And you can also stay for networking. We have time until 10 p.m., especially for networking. So yeah, feel free to go. Nice.
All right.
Thank you. Thanks a lot.
Thank you so much.